the Science Guy.
Bill Nye, the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye, the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Twinkle, twinkle, little star, how I wonder what you are. Up above. Oh, hi, I was just, Well, anyway, outer space is so big, and everything in it is so far away. Do you know how we know? Well, we'll just look. By looking at the stars, we've learned about outer space. And do you know what else? Everything out there is made of the same stuff that we are. Isn't that wild? So, come with me today while we explore the vast, wonderful world of outer space. Outer space is big. We have to go out. Way out. Outer space. Way out here. Whoa. Things in space are very far apart.
What do you mean?
I mean very far apart.
Uh-huh.
Let's say that this little ball is the Earth.
All right.
Yeah, this little ball. And you and I are right here at Nye Laboratories.
Mm-hmm.
How far away do you think the sun would be? Would it be this far away? This far away?
I don't know.
Maybe this far away?
Maybe. Yeah.
No. Watch. Would be this far away.
Whoa.
20 meters. That's right. If the Earth were this big, the sun would be this big, and they'd be that far apart. Now, what about the planets and other stars and galaxies?
I don't know.
Well, they're really far apart. I mean, they're way out there. Our Earth is big, and so is our solar system, sure. But look at the sky at night. Some of those points of light aren't stars. No, they're groups of billions of stars. But they look like a single point of light because they're so far away. Whoa.
Whoa. Whoa.
Whoa. Whoa. Whoa. How long do you think it would take me to get from here to where you are? Well, let's see. Here I come. Took about a second, right? How long do you think it would take the fastest thing in the universe to get from here down there? How long? Well, a lot less than a second, I'll tell you. Here's the fastest thing in the universe. It's light. Light goes 300,000 kilometers every second. Not 300,000 kilometers an hour, not 300,000 kilometers a minute, but 300,000 kilometers a second. The things in the universe, things like stars and galaxies, the things in the universe are so far apart that it can take even the fastest thing there is. It can take even light millions and billions of years to get from one place to another, even at the speed of light, which is pretty fast.
So what you're saying, Bill, is the closest star to our sun is 4.3 light years away?
That's right. Now, a light year is the distance that light travels in a year. Now, light goes pretty fast, and a year is a long time. So a light year is really far. 9.5 trillion kilometers.
Wow. So that means some of the stars we can see right now may not even exist anymore?
That's right, that's right. Maybe a star is burned out and collapsed. Okay, well then it stops giving off light. Well, the light keeps coming here for years. So, in a way, the star doesn't burn out and collapse here until the light stops coming here. Whoa.
Did you know that?
The Great Red Spot on Jupiter is actually a hurricane larger than the Earth.
Now you know.
How far is far? On Earth, far may be to the other side of this lake, or across the city, or across the country. But in space, the sun and moons and planets of our solar system are only tiny dots in the galaxy, and the galaxy is only a tiny dot in the universe. You know, you couldn't get to the nearest star that's our neighbor, even if you spent your whole life traveling. But I digress. The thing to remember is, things in space are really far apart. Whoa. Oh, man. Imagining distances in space is difficult because everything is so far apart. But think of it this way. Let's say that this miniature soccer ball is the size of our sun, and it's right on the goal of a soccer field. Then this speck is Mercury. This is Venus. This tip of a ballpoint pen is our Earth, 2.5 meters from the miniature soccer ball sun. Mars, Jupiter, Saturn, 25 meters from the goal. Uranus and Neptune, 76 meters away. And Pluto's back here, almost out of the building, 100 meters away. How far do you think it is to the next star? Well, it's not in here.
Kids, don't drive this way at home. You could leave tire marks on the living room carpet.
Boy, I hope I unplugged the iron. Hope I didn't leave the stove on. It would be here. The nearest star would be here. 7 hours of highway driving, about 700 kilometers away. And that's only if you think of the star as being this big. I mean, real stars are huge, enormously huge,
Right.
enormously, bigly huge.
All right, already.
Nothing like this. You couldn't get to the nearest star if you traveled your entire lifetime. No way. It's kind of cold out here. Have you ever heard of the Big Dipper? The Big Dipper is a constellation. Now, a constellation is a group of stars that we've given a name to help us find certain stars or recognize them. Now, ancient Greek and Roman astronomers gave all sorts of constellations names, and we still use a lot of those names today, like Orion the Hunter, Cassiopeia the Queen, and the Big Dipper. You know, I don't think the Big Dipper was an ancient Greek or Roman name. If you live in the northern hemisphere, the northern half of the Earth, like right here is Nye Laboratories, one of the easiest stars in the sky to find is the North Star. Sometimes it's called Polaris, and it's right over the North Pole. So North Star, North Pole, Polaris, you with me? Anyway, the Earth's axis, the imaginary line that the Earth spins around, seems to point right to Polaris. So let's take a look through the window of science. You see, Polaris is on the end of the handle of the Little Dipper, and the two stars that form the front of the cup of the Big Dipper make an imaginary line that seems to point right to Polaris. Now get a good look at it, because Polaris won't always be our North Star. No, the Earth's axis is wobbling, just like the axis of this top. See how it forms a small circle? The same is true of the Earth's axis. And eventually, it won't be pointing to Polaris, it'll be pointing to another star, to Vega. But that won't be for about, 12,000 years. So I wouldn't wait up for it.
Okay.
Whoa, dude. This is awesome.
Definitely. Awesome. Oh, I mean, like all those stars. Dude. Oh, there's millions of them.
And like each one of those stars is like a sun.
Like, whoa. Dude. That means that, like, there's tons of other solar systems.
Well, yeah.
Whoa.
And that means that we're like
Like little specks. Oh, like almost nothing. Whoa.
People have always used their eyes to study stars and planets. Sometimes they use astrolabes. You can make one. All you need to do is cut out a piece of cardboard so it looks like this. Then take a protractor and mark off every 10th degree. Now draw lines. Now label them. Then take a straw and tape it on the side. Then take a string that has a washer tied to it and tape it on the other side. There, you're set. Go outside at night and look through the straw and find a star. Find out where the weight hangs on the astrolabe. Come outside a couple of hours later and find the same star. You'll see that it moved. That's because the Earth is turning. Astronomers also use astrolabes to find out the motion of stars and find planets. It's freezing.
I'm Eric Wilkes, and I'm a staff scientist and astronomer here at the Very Large Array. You know, what astronomers do is to try to figure out what is going on with a variety of objects out in space. What we have here are basically radio dishes, these big, giant, curved dishes which receive radio waves coming from some object out in outer space. We look at planets like Mars and Jupiter and Saturn. We look at stars. We look at galaxies, like our own Milky Way, but beyond our Milky Way. What we do is through a variety of computers is we turn that electronic signal into an image. We can then display that image on our computer screen. So most of the science comes in looking at that screen, looking at the image, and really that's really where we do what astronomers do. The basic idea, and as scientists in general and astronomers in particular, our goal is to understand the universe. Whether or not there is Klingons on the other side of the galaxy, I don't know.
Did you know that?
10 tons of meteorites hit the Earth every day. Most are the size of a grain of sand.
Now you know.
Science. Whoa.
About 2,000 years ago, in the town of Alexandria, which is here, near the mouth of the Nile River, what is now Egypt, there was a guy named Eratosthenes. And he was the librarian of the great Library of Alexandria. One day, he came across a note from someone who lived here in the town of Sina. And the note said, at noon on the longest day of the year, Styx cast no shadow, and we can see all the way to the bottom of our wells. Eratosthenes realized that where he lived, Styx did cast a shadow, and he couldn't see to the bottom of wells. And he got to thinking about it, and he realized, the Earth must be round. Yeah, we must be living on a big ball. That's the only way for there to be no shadow here and a shadow here. So he measured the shadow that the stick cast, and then he paid someone to walk from Alexandria to Sina and keep track of the distance as carefully as he could. Well, that distance turned out to be around 800 kilometers, and the shadow was about a 50th of a circle. So then he multiplied 50 times 800, and he got 40,000 kilometers, and that's the distance around the Earth, what we call the circumference of the Earth. So check this out. This guy made observations of a star, our sun, and he figured out the size of a planet, our Earth. The same kind of observations that you can make. Hey, not bad.
فعندها طلب أريتوستنيس من راع كان هناك: يا أخ، امشي إلى سينا وقس المسافة إلى هناك. هل أنت مجنون؟ قال الراعي. المسافة تكشف لي عن حجم العالم، قال أريتوستنيس. ادفع لي بالميل، قال الراعي. وعليه اضطر أريتوستنيس أن يدفع للراعي أجرته مضاعفة، ومضى الراعي في رحلته. إن رجلي متعبتان حتى الموت، قال الراعي.
We are at T-minus 4 minutes and counting. Roger, I'm switching on all 3 fuel cells and main power supply. The launch conditions at Kennedy Space Center are good.
Well, space camp is really just a place where you learn about space and the planets.
Launch control Columbia. All systems ready and the crew is go for launch.
The most exciting part of the day is when we do our missions.
Columbia, start auxiliary power units. Roger, starting all AP.
We train like a real astronaut would. 8, 7.
Well, we ride simulators to teach us about what it would be like in space.
6, 5, 4.
Okay, in the future, I think a lot more people will go to space. It'll be like a regular thing.
3, 2, 1. Booster ignition. Liftoff. We have liftoff. Columbia, you have cleared the tower.
You learn a lot about space and what it would be like to be an astronaut.
Marshall Ops, we are ready to come home. Houston, the payload is secure and ready for re-entry.
Please turn on all 3 fuel cells and switch to all 3 power buttons.
Roger, fuel cells and power system on.
I want to be an astronaut.
Yes, I do want to become an astronaut.
I think that it would be like the best experience that there is.
Correct. Have mission sensors 1. Good job, guys.
Welcome back to the Star Cook.
Thank you. Welcome back. I'm Michaela, and I'm here with my very special guest, Mr. Bill Nye.
Thank you, everyone. Michaela, it's so good to be back on the show, and you are looking fabulous.
Thank you. You too.
Oh, thank you, Michaela.
So tell me, Bill, what are we going to do today?
We have here the ingredients to make virtually anything.
Oh, these are different kinds of atoms.
That's right. These are all the different elements, all the different kinds of atoms in the universe. Now, atoms come from stars. Now, take, for example, our planet. Our planet has a lot of iron and silicon, along with many other elements. And our star has a lot of hydrogen and helium. Now, Michael, oh, that's our hydrogen. Almost lost it there. It's okay, everybody, it's okay. Now, Michaela, you and I are 65% water.
Right.
Now, what's water?
H2O.
That's right, H2O. I have some water here, which I prepared earlier.
Well, of course.
And the water is 2 parts H and 1 part O. H2O, water.
So with this here, we can make virtually anything.
Well, actually, no. Because in order to make all these atoms, you need the force of exploding stars and billions of years. But brownies, on the other hand, only take about 35 minutes.
And even brownies are made of atoms.
That's right.
Oh, Bill, this looks fabulous. People, it looks fabulous, doesn't it?
Oh, thank you. Here, Michael, you please have the first one.
Oh, thank you. Oh, delicious. We'll be right back.
Thank you. Now, people say, why make observations of stars? Why look into space? Are you kidding me? It gives you a perspective of where you are in the universe, of what we do all day. I mean, what are you trying to make some kind of joke? I mean, we are made of the same material as stars. Stars, you, me, the camera, the television you're watching, everything made of the same stuff that stars are made of. So you have to study stars in order to understand what we're made of, for crying out loud.
Whoa.
Well, when I looked up at night, well, there's so much I can tell just by being curious and observational. Well, I'm so observant, baby. Well, I'm so observant. I'm so observant of the sky. Well, we're in a solar system, and solar that means sun, and the sun is one star in a galaxy of billions and billions. Well, I'm so observant, baby. Well, I'm so observant. I'm so observant of the sky. Now its immensity's impressive, and as if that's not enough, stars, planets, all made of the same stuff. Well, we're all made of atoms, baby. We're all made of atoms. We're all made of atoms, you and I.
You know, since the show started, the light coming out of your television set has gone about 540 million kilometers. Now, if it happens to be headed in the direction of the nearest star, Alpha Centauri, it's got another 41 trillion kilometers to go. Now, that's a long trip at the speed of light. So don't go asking me, are we there yet? Are we there yet? It's going to be at least 4 years, okay? Well, if you'll excuse me, got some stellar coordinates to record. See you around the solar system.
Produced in association with the National Science Foundation.